to show you exactly how finance professionals can use AI better than 99% of people, because the reality is that a lot of finance professionals are already working with AI. They're generating forecasts, they're building models, and they're producing analysis faster than ever. And the output often looks perfectly fine. But this is exactly where the difference starts. In real finance work, the standard is not whether something looks correct. The standard is whether the output can be trusted inside a real model, a real reporting pack, or a real decision process. I can tell you that most people are using AI in a way that produces answers, but not in a way that produces controlled, repeatable, and audit-safe work. So in this video, I'm going to walk you through the 5-layer framework that puts you in the 1% of finance professionals who actually know how to use AI in real finance environments. All the prompts and resources I use are available in my free community, linked in the description below. Now let's get to it. Before we get into the framework, let's look at how most finance teams are currently working with AI. Most finance teams use AI as a smart assistant. They paste data, they upload a workbook, they'll ask for a forecast or maybe some commentary, and they'll accept the output the same way they'd accept work from a junior analyst. AI is being used for its efficiency, but without changing how the team actually operates. The result is faster work, but not more controlled work. Now, there are 3 structural mistakes that show up almost every time. The first is silent assumptions, where teams let the AI infer or insert its own defaults instead of asking for explicit assumption capture and sign-off. The second is a weak reconciliation discipline, where outputs are delivered without independent recalculation or clear pass or fail checks for things like bookings versus recognized revenue. And lastly, those loose output standards where table names and formats vary by run and by model, so that outputs are not directly comparable or auditable across cycles. Now, here's what most people get wrong about all this. They think it's a prompting problem, but it's not. A good prompt can improve a single run, but it cannot guarantee the output's legitimacy or its auditability or its repeatability. Default is how it's being organized. Now, prompts are one-off instructions. Operating model rules are persistent requirements that shape every run and every user. Now, if I had to define the real problem, it's that teams treat AI as a tool for speed rather than as a component of a governed financial system. So outputs are fast, but they're not reliably controlled. So what does the top 1% actually do differently? Well, they operate across 5 layers, and let me walk you through each one. The first is the workflow layer. Now, this is where you control and you standardize exactly when and why the model runs, who owns it, which report it feeds, and how its outputs get consumed. Every run must include a run purpose tag, whether that's monthly close, board, or ad hoc, a named owner, and an integration point. When it's missing, then outputs float in isolation, and nobody knows whether a number is a working draft or if it's board ready. Now, the minimum standard I set is a 1-line workflow context at the top of every run with a named owner and a destination tag. Now, if a run is not linked to a process, it gets flagged as exploratory and must not be used in official packs. The second is the prompting standards layer. Now, this is where you define exact input names, required sheets or CSVs, units, date formats, and output table names. And you mandate machine readable tables with fixed column names so results can be programmatically validated and compared across runs. Now, if this layer is missing, well, then you're going to get inconsistent column names, you'll get mixed units and ad hoc outputs that break pipelines and manual audits. Now, the one thing I make sure of is that I ask for an input schema checklist, ISO date usage, fixed table names, and a one-paragraph assumptions block that must appear before calculations. Now, the third layer is the validation layer, which is the layer that proves the math. You standardize the set of reconciliation identities and tolerance rules that must be checked automatically. Things like customer roll forward identity, ARR bridge identity, and numeric bounds like churn between 0 and 10%. Now, when this layer is missing, subtle arithmetic errors slip into KPIs and into board packs, and you can't trust the output. My standard here is at least 2 independent recomputations and explicit tolerance of 1% automatic pass-fail flags and a stop and fix rule when a control fails. The fourth layer is the governance layer, which is about making assumptions visible and traceable. You log assumptions, you log their source, whether actual, estimate, or default, the model version, the preparer, and a short change log. Silent defaults are forbidden, and any default must be flagged and approved. Now, if this layer is not there, models become black boxes where assumptions drift, approvals are missing, and audits cannot be traced back to the numbers. Now, what I enforce here is an assumptions table listing parameter, value, unit, source, and approver, and a rule that any inserted default must be explicitly marked and either removed or approved within 1 business day. The fifth layer is the executive output layer. This is where you standardize a short executive summary capped at 5 bullets, a required 1-page bridge or chart, and the exact tables executives expect. Now, language rules are enforced to make sure there's no technical jargon in the summary, and we have 1 action item per bullet. When this layer is missing, analysts produce long, messy reports that executives often ignore or misread, and then important risks get buried. Now, my expectation is a 1-page executive sheet labeled artifacts with table names that match the prompting standard, and a 5-bullet narrative covering the top number, the top risk, and the recommended action. Now that you know all the 5 layers, I'll show you how to execute them and test everything in a real finance scenario. We take 1 practical SaaS ARR forecasting use case and run it twice using the exact same data set. First, we use a normal prompt, the way most professionals currently use AI. Then we run the same task using the structured 1% framework with defined workflow placement, assumption control, validation rules, reconciliation checks, and executive formatting. The objective is simple. We want to see what actually changes. Think of it as comparing 2 analysts building the same forecast. One gives you numbers and a polished file, and the other shows you the assumptions used, proves the totals reconcile, flags control failures if they exist, and structures the output for board reporting. Both look competent, but only one operates inside a controlled financial system. The use case is a driver-based SaaS ARR forecast. The business is a growing SaaS company with a starting ARR of 2.5 million USD, monthly customer acquisition, monthly churn, 3 pricing tiers, expansion impact, and monthly board reporting. The CFO needs a 12-month forecast that tracks customer roll forward, bridges ARR movement, calculates revenue, and feeds executive reporting. The version 1 prompt goes like this. We ask for a 12-month forecast for customers, revenue, and ARR using the assumptions provided here. The output file needs to be in an Excel file. That's it. There's no structure, no validation or reconciliation requirement, and no formatting rules. What came back was a downloadable Excel file. This is exactly the danger zone. Even though the output looked good, several structural risks exist. The first is assumption control. Now, the risk here for assumption control is that the model stated it used assumptions from the assumption sheet or applied sensible default if something was missing. Now, that might sound very reasonable, but in finance, this is a serious governance issue. A financial model cannot quietly insert its own assumptions without explicit approval. And when the prompt does not force the system to list exactly which assumptions were used and confirm no defaults were introduced, then hidden logic enters the model. Decision makers may then rely on numbers that are partially based on unverified inputs. The second is that there was no explicit reconciliation requirement. The prompt did not demand an independent recalculation. It did not define an acceptable variance threshold, and it did not require a failure flag if numbers did not tie. Now, in finance, reconciliation is not optional. Without enforced reconciliation rules, errors can then pass unnoticed. The third point is that there was no workflow context. The beginner prompt did not place the model inside a real financial process. It did not specify that this forecast feeds a board report or integrates into the monthly close or connects to governance controls. And as a result, the AI behaved like a helpful analyst answering a question, not like a controlled system operating within a reporting framework. And when AI does not understand where its output will be used, it optimizes for helpfulness rather than control and reliability. For the fourth point, it seems that validation was optional, not structural. Now, even though the beginner output included validation sheets, those checks were not structurally required by the prompt. The AI chose to include them but was not obliged to enforce them. There was no mandatory pass or fail result, no defined consequence if thresholds were breached, and no instruction that output must stop if controls fail. In controlled finance environments, validation must be embedded as a rule and not just a suggestion. The fifth is that there was no output discipline. The beginner prompt did not specify formatting rules, didn't specify table structure or naming conventions or required output sections. And that means the final result depended on how the AI decided to respond rather than on a predefined system standards. Now, let's build version 2, and I've constructed the prompt using techniques and tactics that only the top 1% use. The exact prompt used placed the model inside a monthly SaaS reporting workflow from the very first line, specifying that it feeds the monthly executive ARR bridge and board reporting pack. It also required the model to build a 12-month driver-based forecast covering customer roll forward, bookings, revenue recognized, and ending ARR. I specify here that only assumptions from the Assumptions tab could be used, and that those assumptions must be explicitly listed before calculations. It defined the exact modeling structure for the customer roll forward and ARR bridge. It set mandatory validation controls, including independent recomputation of customer roll forward and ARR bridge, a control failure flag if imbalance exceeded 1%, confirmation that pricing mix percentages sum to 100%, and confirmation that churn rate sits between 0 and 10%. And it also prescribed a strict output format covering an assumptions used table, a customer roll forward table, and an ARR bridge table, as well as a validation results pass fail table and an executive summary capped at 5 bullet points. Now, let me show you what these changes do. The workflow layer placed the model inside a defined financial process, which changed its behavior significantly. When AI understands where the output will be used, it operates with much higher discipline. It is no longer just answering a question, it's producing a component of a financial reporting system. The prompting standards layer removed ambiguity almost entirely. Assumptions had to be explicitly listed before calculations, output sections were predefined, and table structures were mandated. Naming conventions were enforced, and using this prompt reduced AI's freedom to improvise. In the finance world, consistency is more important than creativity. The validation layer makes reconciliation non-negotiable. Independent recalculation of the customer roll forward and the ARR bridge is required. A tolerance threshold of 1% was also defined, and if the numbers did not reconcile with that threshold, the model had to flag a control failure. Now, the governance layer eliminated any hidden logic, and the model was required to use only assumptions from the dataset. And most importantly, list those assumptions explicitly before building the forecast and disclose anything missing. Now, silent defaults were not allowed at all, and the executive output layer was designed for the final result for the decision makers, not just analysts. Now, tables were structured and clearly labeled, validation results were separated into their own section, and the executive summary was limited and focused. The 6 validation steps explicitly executed in version 2 were independent customer roll forward recomputation, independent ARR bridge recomputation, tolerance threshold application, pricing mix integrity confirmation, churn bounds confirmation, and an explicit pass or control failure statement. So what actually changed between version 1 and version 2? Well, in version 1, reliability depended on how responsibly the AI chose to behave. It could insert defaults, it could skip reconciliation, or it could make implicit assumptions without being forced to disclose them. While in version 2, reconciliation was made essential. A tolerance threshold was defined and assumption control was enforced. In version 1, validation existed but without any enforcement. The checks were informational rather than authoritative. And version 2, validation was done properly, where independent recalculations were required, thresholds were defined, and failure had to be explicitly flagged. Now, both versions used the same dataset, the same AI, and both produced a 12-month forecast. Now, on the surface, they may even look similar, but structurally, they are completely different because version 1 behaved like a capable junior analyst producing work in good faith, whereas version 2 behaved like a controlled financial system operating inside a defined set of rules. And that's the real distinction between average AI use and the top 1% operating discipline in finance. And that's it for this video. If you want the full prompt library used in the video and all the other videos, everything is linked in the description below, and you can join the community to go even deeper. So let me know what you think in the comments, and I thank you for watching, and I'm looking forward to seeing you next time.